Welcome to the Future Chi Podcast.
Welcome back. We have a massive investigation lined up for you today.
We really do.
If you've been listening to our recent conversations, you know we've been circling this idea of functional medicine, specifically that analogy of the check engine light.
It's a classic. Every practitioner uses it.
Exactly. It's a staple in every clinic.
Yeah.
Right? The body signals a problem, an imbalance, long before the engine actually blows up.
We accept that premise. It's foundational to what we do.
We live by that premise.
Yeah.
But here is the problem with that analogy, and something that, honestly, it keeps me up at night. A light on a dashboard implies a wiring system.
Exactly. You don't get a signal on a dashboard without a physical copper wire connecting that light to the engine block.
Right.
Information doesn't just, teleport from the engine to the driver. It has to travel along something, a physical pathway.
And for 2,000 years, Chinese medicine has been incredibly good at reading the signals.
Uncannily good.
You look at the tongue, you feel the pulse, you track symptoms along these very specific pathways. We know the signal exists. The results are there.
The clinical effects are undeniable.
But for centuries, Western anatomists have opened up the human body, looked inside, and said, there is no wire.
You don't see it. They claimed the connection was, imaginary because they couldn't find the hardware.
You could see the big stuff.
Oh, absolutely. They could see the nerves, they could see the blood vessels, they could see the lymphatics, all the major systems.
But this third network that TCM describes, this thing that connects the skin to the internal organs.
They couldn't find the physical structure, and so the conclusion for a long, long time was that the ancients were just speaking in metaphors.
That it was poetry, not anatomy.
Precisely. That chi. It was just a useful fiction to describe a process, but not a substance flowing through a physical duct.
So that is our mission today. We're going to peel back the dashboard.
We're popping the hood.
We're going to look for the physical hardware of the Meridian system. And to do that, we have to start with a concept that might seem completely unrelated to acupuncture or anatomy.
At first, yeah, it seems like a total detour.
We need to talk about astrophysics.
We do. We need to talk about dark matter.
Okay, let's unpack this. Because usually when we're talking about anatomy, we are not talking about the cosmos. But you've argued that this analogy is actually the perfect lens.
I think it's more than an analogy. It's the philosophical spine of this entire investigation. It's the exact same intellectual problem, just on a different scale.
So walk us through it. What is dark matter?
Okay, so if you talk to an astrophysicist today, they will tell you that everything we can see, all the stars, the planets, the galaxies, the gas clouds, all of it makes up less than 15% of the universe.
Just 15%.
Less, maybe. Some say 5. The other 85% of the mass in the universe is what they call dark matter.
And dark means what exactly? That we just can't see it.
It means it's completely invisible to us. Telescopes can't pick it up. It doesn't emit or reflect light. You can't touch it. It doesn't interact with the electromagnetic spectrum at all. Our current sensors are totally blind to it.
So how on earth do they know it's there? How do they know it's not just, a rounding error in the math?
Because of the effects. It's all about the effects.
What kind of effects?
Gravitational effects. They look at a galaxy, right? And they see it rotating. They can measure the speed of the stars at the outer edge of that galaxy.
Okay.
And those stars are moving at speeds that shouldn't be possible based on the visible matter, the stars and planets we can see.
What do you mean shouldn't be possible?
I mean, based on the visible mass, there isn't enough gravity to hold the galaxy together. Those outer stars should just fly off into space. The whole structure should tear itself apart.
But it doesn't.
It doesn't. It holds together. So astronomers have to infer the existence of a massive, invisible structure, a halo of this dark matter that's providing the extra gravity needed to keep the galaxy intact.
So they can't see the thing itself, but they can see what it does.
Exactly. They know the structure is there because the galaxy is behaving in a way that requires it. The effects prove the existence of the cause, even if the cause is invisible.
I see where you're going with this. The parallel is, it's really striking.
It's the exact same situation. For 2 millennia, TCM practitioners have mapped an invisible network based entirely on clinical effects.
You put a needle in the leg, the stomach stops hurting.
Right. You stimulate a point on the hand, the headache resolves. You warm a point on the low back, the person feels energy throughout their entire body. The galaxy is rotating, so to speak.
The effect is there. The body is regulating itself in a way that nerves and blood vessels alone cannot fully explain.
It holds itself together in this coherent, networked way. There's a coherence that our known anatomy doesn't account for.
But the critics have always said, show me the structure. If I can't cut it out and put it on a slide, it's not real.
Precisely. And what we are proposing today is that maybe the critics weren't wrong about the anatomy being elusive. They just had the wrong telescope.
They were looking for a copper wire with a scalpel.
When they should have been looking for a fiber optic cable with a completely different kind of sensor. Maybe the dark matter of the human body has been there the whole time, but our dissection tools were just too blunt, too crude to find it.
And that brings us to our cold case. And I want to frame it that way because this story has all the elements of a noir mystery.
It really does.
We have a brilliant scientist, a paradigm-shifting discovery, a government cover-up, and then a 40-year silence.
It's a genuine tragedy, both for the man himself and for science. We have to go back to 1963 to North Korea.
A place not exactly known for scientific transparency.
Yeah, and that's key to the story. There was a surgeon there named Dr. Bong-Han Kim. He was a massive figure in the scientific community there at the time. We're talking professor of physiology at Pyongyang Medical University. A big deal.
And in 1963, he publishes a paper.
Several papers, actually. And in them, he claimed he had found it. He claimed he found the physical canals of the acupuncture meridians.
And let's be crystal clear, he wasn't talking about energy lines or metaphors. He wasn't even talking about fascia planes, which is a more modern theory.
No, this was not a theory of function. This was an observation of structure. He was talking about plumbing.
Plumbing.
He found these thread-like tubes floating inside large blood vessels and also inside lymph vessels and running along the surface of organs.
So not just near them, but physically inside the existing vascular system.
Correct. And he developed a whole new vocabulary for what he was seeing because it didn't exist in any anatomy textbook. He called the tubes Bonghan ducts. He called the nodes where they gathered Bonghan corpuscles.
And he found something inside them, right? This part is crucial.
It is, because a tube is just a tube unless it has something flowing through it. He found a fluid, and inside that fluid were these tiny granules that contained DNA.
DNA. So they were carrying genetic information.
They were. And he gave them a very specific, very poetic name. Sanal.
Sanal.
It's a Korean word. It literally means live eggs.
Wow. Live eggs. That is a very evocative name.
It is, isn't it? He believed these sanal were the fundamental seeds of life, capable of regenerating tissue. He was basically describing stem cells and their transport system decades before the rest of the world had fully conceptualized them.
He was on the verge of revolutionizing biology.
Absolutely. The Nobel Prize Committee should have been calling, but then in 1965, everything just stopped.
This is the part of the story that just gives me chills.
It's terrifying. His lab was shut down. His papers were removed from circulation, declared state secrets. Dr. Bong-Han Kim vanished.
Gone.
To this day, we don't know exactly what happened to him. The most likely theory is that he was purged by the regime, but we don't know if that means execution, imprisonment, or forced labor. He just disappeared from history.
And the science disappeared with him.
That's the scientific tragedy. He hadn't fully documented his methods, especially the specific chemical stains he used to make these transparent tubes visible. So for 40 years, the trail went completely cold.
And the Western world just wrote it off.
Completely. As North Korean propaganda or, just bad science, pseudoscience, the case was closed.
Until the early 2000s.
Right. It wasn't until around 2002 that a team at Seoul National University in South Korea decided to test the myth.
And they were led by a physicist, not an anatomist.
That's right, a physicist named Dr. Kwang-Sup-So. He approached it not from a medical standpoint, but from a physics problem of light and optics. He wanted to know, fundamentally, was Bong-Han Kim lying?
And this whole journey is documented, right?
It is, and it's documented beautifully in a book by a Korean writer named Kim Huangdi. The book is called A Journey Through the Body's Chi with a Physicist, and it recounts this entire incredible resurrection of lost science.
So what did Dr. So's team find? Did the ghost exist?
They found them. Using modern fluorescent dyes and specialized microscopy, they found the threads exactly where Bong-Han Kim said they were. Floating in the lymphatic vessels, inside blood vessels. They were real.
But in finding them, they also realized why everyone else for the last 2,000 years had missed them.
Exactly. If they're right there, inside the blood vessels, why don't we see them when we draw blood or do surgery?
Yeah, what's the reason?
There are three big reasons. The first is size. They are microscopic. We're talking about 20 to 50 micrometers in diameter. That's smaller than a human hair.
Okay, so they're tiny.
Second, they're incredibly fragile. Think of a tiny, tiny wet noodle. If you cut into a patient during a normal dissection or surgery, the tension in the surrounding tissue breaks these threads instantly, and they snap back and curl up like a broken rubber band. They effectively disappear into the background noise.
So the act of looking for them destroys them.
In many cases, yes. But the third reason is the real kicker.
And that is?
Transparency. This is the big one. The refractive index of these tubes is almost identical to the lymph or the blood plasma surrounding them.
Can you explain what that means, refractive index?
Sure. It's basically a measure of how much light bends when it passes through a substance. Because the PVS has the same refractive index as the fluid it's in, light passes right through it without bending. It's like trying to see a clear glass rod dipped in a beaker of water. It becomes invisible.
So unless you have the exact right dye to stain it and make it pop?
You'll look right through it. It's the body's dark matter. It was there all along. We were just anatomically blind to it.
So Dr. So's team renamed it the Primo Vascular System, or PVS.
Correct. They wanted to move away from the political baggage of the name Bonghan and just describe the structure itself. Primo, as in primordial, implying it forms very early in embryonic development.
Okay, so we have a rediscovery. A 40-year-old cold case is solved. But we promised our listeners, especially the practitioners and students tuning in, that we would treat this like investigative journalism, not a sales pitch.
Absolutely. We have to.
We need to be skeptical. Because if this is real, it changes everything we know about anatomy and physiology. But there are some very serious attacks against this theory that we need to address head-on.
We have to be brutally honest here. If we're going to build a case, we also have to try to tear it down. There are three main arguments against the PVS, and they are strong, reasonable arguments.
If we want to trust this science, we have to face the skepticism.
Without a doubt.
So let's start with attack number one. And this is probably the most damaging one, if it's true. The fibrin artifact argument.
The dirty lens argument, yeah.
Critics are essentially saying that what these researchers are seeing isn't a new organ system at all, it's just a blood clot.
Right. And you have to admit, it's a plausible argument at first glance. When you take blood or tissue out of the body, it immediately starts to coagulate.
It's a natural process.
A totally natural process. And as it clots, it forms these little protein strings called fibrin. And if you look at fibrin threads under a microscope, they look a lot like these PVS threads. There was even a study by a researcher named Jing who showed that if you induce hypercoagulation, if you make blood clot in a certain way, it mimics the PVS structures almost perfectly.
So play the devil's advocate for me.
Yeah.
If I'm a skeptic, I'm saying you guys are just looking at coagulation strings and calling it a meridian. Case closed.
And that is a very reasonable objection that needed to be addressed. But here is the rebuttal, and it's a powerful one. It all comes down to looking closer. The fibrin argument only works if you do not look closely enough.
How so? What do you see when you zoom in?
Well, the first thing is that a blood clot, a fibrin string, does not have a cell lining.
It's just protein.
It's just a solid string of protein. But when researchers, and this is specifically the work done at Auburn University, which we'll get to, looked at these PVS structures with high-powered electron microscopy, they found a hollow lumen.
A lumen? So it's a pipe, not a solid string.
It is a pipe. And crucially, that pipe is lined with cells. Specifically, endothelial cells.
Let's pause on that because that's a term our listeners need to understand. Endothelial cells.
Right. These are the specific, specialized cells that wallpaper the inside of every blood vessel and lymphatic vessel in your body. They form a smooth, continuous lining.
And you can't fake those.
You cannot fake endothelial cells. A blood clot cannot spontaneously decide to grow a perfect cellular lining with specific rod-shaped nuclei. It's biologically impossible.
So the histology is completely different.
Day and night. And on top of that, fibrin doesn't carry cargo. It's just a net. The PVS threads, these pipes, are filled with a flowing fluid. And that fluid is carrying the DNA granules and pluripotent stem cells.
So one is a dead protein net. The other is a living cellular tube actively transporting regenerative material.
Exactly. So once you do the histology, once you actually look at the cellular structure, the fibrin argument just... it completely falls apart.
Okay, that feels like a solid rebuttal. Let's move to the second attack, which is more about the scientific community than the science itself, the small club problem.
This is a credibility issue, and it's a fair one. For a long time, almost all the research on the Primo Vascular System came from Dr. So's team and a few colleagues in Korea.
Okay.
And they were primarily publishing in CAM journals, that's complementary and alternative medicine journals, rather than mainstream high-impact anatomy journals like Nature or Science or Cell.
Which, to an outsider, can create an echo chamber effect, right? It can look like a small group of friends all confirming each other's work, but no one from the outside is verifying it.
It does. And in science, that is a legitimate red flag. You need independent verification. If only one lab in the world can produce a result, it's not considered confirmed.
So how did that change?
There was a crack in that wall, a big one. And you mentioned it a moment ago, Auburn University.
Right, the 2016 study in the U.S.
This was huge for the field. Auburn is a major American research university. Their veterinary medicine and biology departments are top-notch. And they had no dog in the hunt, you know.
They weren't trying to prove or disprove acupuncture.
Not at all. They weren't trying to prove ancient wisdom was right. They were just biologists checking a strange anatomical claim, and they independently replicated the findings.
What did they confirm specifically?
They found the ducts, they found the nodes, they confirmed the hollow structure, the endothelial lining, the rod-shaped nuclei, the presence of DNA-carrying fluid, everything. They saw it too.
And that changes the game.
That was the turning point for credibility. When a skeptical, independent, mainstream lab in another country reproduces your work, it stops being a small club, and it starts being an emerging scientific consensus.
Okay, that addresses the echo chamber. But that brings us to the third attack, which is maybe the hardest to overcome right now, the invisibility problem.
Wait, N-rays comparison. Yeah, this is the big hurdle.
Can you just briefly explain the N-rays story?
Sure. In the early 1900s, a French physicist claimed to have discovered a new form of radiation called N-rays. The problem was nobody else could see them. It turned out he was just imagining it. It was a psychological artifact. He was seeing what he wanted to see.
And critics are saying PVS is the modern N-rays.
Exactly. The argument is, if this system is so important, why can't we see it in a living human? We can only image it by injecting toxic fluorescent dyes into animal models or excised tissue. We can't stick a probe on a living person and see the meridians light up. Not yet.
So is that a deal breaker? Does that invalidate the whole thing?
No, I don't think so. And here's why. The transparency isn't an excuse made up after the fact. It's a predicted physical property of the system.
Because of the refractive index.
Right. It should be invisible to normal light. The physics says so.
Yeah.
So the fact that it's hard to see actually fits the model. But I will admit, this is the biggest operational hurdle. Until we can develop a non-invasive technology to image it in a living, breathing patient, there will always be a sliver of doubt for the hard skeptics.
And we're going to talk about the technology that might solve that problem later on.
We are. And it's closer than you think.
Okay, so let's recap where we are. We've established that there is very likely a real physical hardware here. It's not just blood clots, and it's been verified by independent labs.
The evidence for the structure is solid.
So now comes the big question, what is it doing? If blood vessels carry fuel, oxygen, and nutrients, and nerves carry data, electricity, what is the PVS carrying? What is its fundamental role?
This is where it gets really fascinating, because it's not just doing one thing. Think of the PVS less like a simple pipe and more like a multi-lane superhighway.
A superhighway.
Yes. It's a single structure, but it's carrying 3 completely distinct types of cargo, each with a different function, all at the same time.
Okay, let's break down the lanes. Lane 1, what's in it?
Lane 1 is regeneration. This is what we could call the Sannel lane.
Back to the live eggs.
Exactly. The research is showing that the fluid inside these vessels, the Primo fluid, is packed with pluripotent stem cells, and those DNA microgranules Bong and Kim first identified.
Pluripotent. Let's define that term.
Pluripotent means they can differentiate into almost any type of cell in the body. A heart cell, a liver cell, a skin cell. They are the body's master repair crews.
So the PVS is essentially a distribution network for the body's regenerative raw materials.
That's a perfect way to put it. It delivers the repair crews and the blueprints, the DNA in the Sannel, to wherever they're needed to rebuild damaged tissue.
And that makes it fundamentally different from the other systems.
Completely different. The blood feeds the tissue. The nerves instruct the tissue. The PVS rebuilds the tissue. It's the missing leg of the stool. Nutrition, information, and regeneration.
Wow. Okay, that's a massive function. What about lane 2?
Lane 2 is communication. But it's not just the slow chemical communication of hormones or the simple electrical communication of nerves. It's also optical.
Optical. You mean light?
I mean light. Biophotons.
Okay, that sounds like science fiction. What are biophotons?
They're ultra-weak light emissions that are produced by living cells during metabolic processes. It's a known phenomenon. And it appears that the collagen structure of the PVS acts like an optical waveguide.
Like a fiber optic cable.
It's the body's fiber optic network. You know how fiber optics are so much faster and can carry more information than old copper wires because they use light?
Sure.
The PVS seems to be doing the same thing. It's transmitting information at the speed of light through the body.
So when the ancient texts talked about qi having properties of clarity and light,
They might have been describing something quite literal, a flow of photons. But it's not just light. The PVS also contains what are called excitable cells, which means they can carry an electrical signal, similar to nerves.
so it's both electrical and optical.
It's a hybrid system, and this gives us that aha moment when we think about the speed of meridian propagation. You needle a point, and the patient feels a sensation travel up the channel instantly.
Right, it's too fast for a chemical signal to diffuse through tissue.
Way too fast. But it's the perfect speed for an electrical or an optical signal. The PVS explains the speed of qi.
Okay, so we have a repair lane and a fiber optic lane. What's in lane 3?
Lane 3 is immune defense. This is the police lane.
The police.
The Primo nodes, the Bonghan corpuscles, are absolutely packed with immune cells. We're talking mast cells, eosinophils, macrophages. These are the heavy hitters, the first responders of the immune system.
And this connects directly to the clinical effects of acupuncture, doesn't it?
It's a direct link. We all know from practice and from research that acupuncture has a powerful anti-inflammatory effect. For a long time, the mechanism wasn't totally clear.
We just knew it worked.
Right. But now we have a potential mechanism. If you are mechanically stimulating a PVS node with a needle, you are basically poking the police station. You're mobilizing these immune cells. You're trafficking them down the PVS highway directly to the site of injury or inflammation.
So you're not just moving energy, you're physically directing immune cell traffic.
You're directing the body's own anti-inflammatory and repair crews. It's a physical, mechanical, and biological event,
Regeneration, communication, and defense, all in one network.
all rolled into one. And I want to pause here for a second and speak directly to the students and the practitioners who are listening, because lane 1, that stem cell lane, brings us to a concept you deal with every single day in the clinic: Jing.
For me, this is the biggest emotional connection. This is where the ancient texts and the modern lab bench just shake hands.
It connects everything. It's the Rosetta Stone.
So for anyone who might need a refresher, define Jing for us in the classical sense.
In traditional Chinese medicine, Jing, or what we call essence, is the most fundamental substance in the body. It's stored in the kidneys. It governs growth, development, reproduction, and aging.
And the most important thing about Jing
Is that it's finite. You inherit a certain amount from your parents at birth, and it naturally declines as you age. It's like a candle that slowly burns down. When the Jing runs out, life ends.
Okay, now put that idea next to the modern biology of stem cells.
It is the exact same curve, the exact same story. Your body's pool of pluripotent stem cells is finite. It is at its peak when you are young, and it declines steadily as you age.
And when your stem cell pool is depleted.
Your organs can no longer repair themselves effectively. You become frail. You succumb to age-related diseases. The depletion of your stem cell reserves correlates directly with death from old age.
So when a practitioner says a patient has Jing deficiency, that's not a metaphor anymore.
No, it's not some mystical, abstract concept. Jing deficiency is very likely a measurable biological state, a decline in the number and viability of stem cells being transported by the Primo Vascular System.
And nourishing Jing with herbs or acupuncture.
Is not a magical act. It's likely stimulating the mobilization of your remaining stem cell reserves from the PVS nodes and improving the function of this transport network.
That bridges the gap completely. It takes one of the most profound concepts in TCM, vital substances, and grounds it in cellular biology.
It validates the ancient observation. They didn't have microscopes, but they were brilliant observers of pattern. They saw the pattern of aging and called it Jing. We see the cellular mechanism and call it stem cell depletion. It's the same thing.
That's incredible. And there's another one of these profound and frankly baffling ancient concepts, the Sanjiao.
Ah, yes. The triple burner. Organ that is not an organ.
Every student struggles with this one. The texts famously say it has a name but no form. What on earth is that supposed to mean?
It's a total riddle. And for centuries, anatomists have said, see, they were just making things up. There's nothing there. But if you look at the properties of the PVS, it solves the riddle of the Sanjiao perfectly.
Let's do it. Let's look at the comparisons side by side.
Okay, let's list them out. Classical text. The Sanjiao governs the waterways.
In the modern finding.
The PVS literally runs inside the blood and lymph vessels. It is physically navigating the body's waterways.
Check. What's next?
Classical text. The Sanjiao connects the three cavities, the thorax, the abdomen, and the pelvis, the three burners.
Modern finding.
The PVS is a continuous network found physically present in all three of those body cavities, linking the organs together like a web.
Okay.
Classical text. The Sanjiao distributes source qi, or yuan qi, from the kidneys.
And we just said yuan qi is closely related to Jing.
Exactly. And what does the PVS distribute? It distributes stem cells and the DNA-carrying signal, the very essence of life and regeneration. It distributes the source code for the body.
That's a direct parallel. And the last one.
The final, most telling clue. Classical text. The Sanjiao has no form.
Modern finding.
The PVS is invisible without fluorescent dye. To the naked eye, even to a standard microscope, it has no form.
That's uncanny. The descriptions match perfectly.
They match perfectly. If you were an ancient physician observing the functions of the body, and you were to describe this invisible, formless network that connects everything, manages fluids, and distributes life essence, you would invent the concept of the Sanjiao.
And if you were a modern scientist with an electron microscope?
You would discover the Primo Vascular System. It is the physical structure that fits every single functional descriptor of this mysterious non-organ.
And this isn't just us connecting the dots after the fact. There's a specific quote, isn't there? From the Huangdi Neijing, the Yellow Emperor's inner canon.
Yes, and this line is essential for every practitioner to know, because it's the ultimate rebuttal to the idea that the ancients were confused.
What does it say?
The text says, and I'm paraphrasing slightly for clarity, the vessels of blood are visible, the vessels of qi are invisible.
Let that sink in. The vessels of qi are invisible.
That one line proves that 2,000 years ago, they were not confused. They didn't look at an artery and think it was a meridian. They explicitly knew there was a second system.
A circulatory system for blood that you could see, and a circulatory system for qi that you couldn't.
They were describing anatomy that they knew existed based on its function, but which they knew was physically invisible. They weren't imagining things. They were describing the PVS. They were describing anatomy we lost the ability to see for 2,000 years and are only just now rediscovering.
We've talked about the history, the anatomy, the philosophy. Now I want to get into the really sharp end of the stick. Clinical application.
Where the rubber meets the road.
Because this isn't just about validating ancient theory. It's about solving modern problems, life and death problems, specifically cancer.
Right. And this is where the subway analogy becomes very important and, frankly, a bit scary.
Explain the subway analogy for us.
Okay. So imagine your immune system, your T cells, your white blood cells floating in your bloodstream. Imagine they're the police. They are patrolling the main streets of the city looking for bad guys.
And cancer cells are the bad guys.
The ultimate bad guys. If a tumor sheds a cancer cell into the bloodstream, the police often catch it. The immune system can often neutralize it.
But obviously, cancer spreads.
Yeah.
Metastasis happens. So how does it evade the police?
It goes underground. It takes the subway.
The PVS is the subway.
The PVS is the subway. Research from several labs is now suggesting that cancer cells have figured out how to hijack this network. Because the PVS is a protected channel designed to transport stem cells, which look and behave a lot like cancer cells in some ways, the cancer cells can slip into these ducts.
And travel stealthily.
They can travel all over the body in these hidden tunnels, completely avoiding the immune police patrolling the bloodstream.
And this would explain some of the strange metastasis patterns we see, wouldn't it? Sometimes cancer spreads to a location that doesn't make sense based on blood flow.
Exactly. But it makes perfect sense if it's following the Meridian pathways, the PVS network. And this leads to a very grave, very practical warning for all acupuncturists.
Which is?
There is an ancient rule. Never needle a tumor. They called the area around a tumor poisonous earth.
And now we have a potential biological reason why.
We do. If you needle directly into a tumor, or even into the tissue immediately surrounding it, you might physically pierce the subway tunnel. You could breach the PVS duct and inadvertently release a flood of those cancer cells into the stem cell highway.
You could actually be speeding up the metastasis.
You could be. It's a very sobering thought, and it validates that ancient caution with modern anatomy.
It is.
Yeah.
But there's a flip side to the subway analogy.
There is.
If we know the subway exists, if we have the map, we can use it too, right?
That is the incredible hope. That is the therapeutic breakthrough that's on the horizon. And this brings us to one of the most exciting potential applications, bypassing the blood-brain barrier.
The BBB. It's notorious in medicine.
It's the brain's fortress. It's a layer of specialized cells that blocks almost all toxins, pathogens, and drugs from getting out of the blood and into the brain.
Which is great for protecting the brain, but terrible if you're trying to treat a brain disease.
Exactly. It's why treating something like glioblastoma, a deadly brain cancer, is so incredibly difficult. The chemotherapy drugs can't get to the tumor.
The wall is too strong.
But the PVS, the subway system, it seems to connect the entire body, including the brain and spinal cord. There is research, particularly out of Korea, suggesting that if you inject a drug into a primo node at a specific acupuncture point—
Which one?
the famous one, ST36 Zuzanli.
Leg 3 miles. The point every first-year student learns for building qi in blood.
That's the one. The research suggests that if you inject a drug, say a nanoparticle-coated chemotherapy agent, into the primo node at ST36, it enters the PVS subway.
And it just travels up.
It travels up the network, completely bypassing the blood-brain barrier in the blood vessels, and delivers its cargo directly into the brain and spinal cord.
That is revolutionary. You're taking the ancient point for tonifying the whole body and turning it into a cutting-edge biological port for neurodrug delivery.
It is the most beautiful synthesis of ancient knowledge and modern technology you can imagine. We aren't just stimulating the point with a needle anymore. We are using the physical anatomy of the point to solve one of modern medicine's most intractable problems.
Wow. Okay, before we move to the future, I want to resolve one last debate. It's a debate I know our listeners have heard a million times in classrooms and at conferences.
Oh, I know where you're going with this. The fascia debate.
The fascia versus channels war. Is the meridian the fascia, or is it this other thing, the PVS? Which is it?
And the answer, which is so often the case in biology, is not either. The answer is, it's both. They work together.
How so? Unpack that for us.
Okay, think of the fascia, the connective tissue that webs through our entire body. Think of it as the terrain.
The landscape.
The landscape, exactly. It's the connective tissue, the ground substance. It's the spaghetti that physically wraps around the acupuncture needle when you twist it. That mechanical grab sensation that we feel, that's the fascia.
Okay, so fascia is the terrain, the spaghetti.
But the PVS is the river or the wire that runs through that terrain. The PVS threads run inside and along the fascial planes. The fascia creates the pathway. The PVS is the signal carrier within that pathway.
So when we talk about qi, that classic sensation of the needle grabbing and then a signal traveling, it's a two-part event. It's a team effort.
Precisely. The grab is the fascia wrapping the needle. But that mechanical wrapping creates tension and a piezoelectric charge that stimulates the PVS thread running through that fascia.
So the fascia provides mechanical coupling.
And the PVS provides the high-speed signal transmission. You can't have one without the other for the full effect. The PVS is the signal wire inside the fascial spaghetti.
I love that. It ends the argument. It's not a competition, it's a partnership.
It's an integrated system.
So we've covered the past, we've covered the present. Let's look to the future. You mentioned earlier that the biggest problem, the N-rays problem, is we can't see this in living patients yet. Toxic dyes are a no-go for humans.
Right. That's the current bottleneck.
What is the solution? What's on the horizon?
The solution is coming, and I think it's coming fast. I'm willing to make a prediction. By 2030, the game will change completely, and it will change because of a technology called FLAME.
FLAME. That's a great acronym. What is it?
It stands for Fluctuation-Based Super-Resolution Acoustic Microscope. It's a new type of super-resolution ultrasound.
Okay, and why is this specific technology the key?
Because of the resolution, the size. Remember we said PVS threads are about 20 to 50 micrometers wide?
Right, smaller than a hair?
Standard medical ultrasound is way too blurry to see something that small. It's like trying to read a newspaper with a foggy pair of glasses. But FLAME technology is already hitting that 50 micrometer threshold. It's getting sharper and sharper every year.
So the vision is Exactly. What does this look like in the clinic in 2030?
The vision is that a practitioner could put a small probe on a patient's wrist at the pulse position, just like a little ultrasound wand, and on a screen next to them, they would see the meridian map light up in real time.
You'd actually see the PVS.
You would see the PVS structure pulsing. You'd see the flow. There'd be no more guessing where the channel is. There would be no more, it's about one thumb width over. You would see it.
No magic.
No magic, just physics. That is the moment the skepticism dies for good. When you can take a clear picture of it in a living human, the debate is over. It becomes part of the anatomy textbook.
That is an absolutely incredible future to look forward to.
It is. And it's not science fiction. The technology is already in the lab. It's just a matter of refining it and making it affordable.
We've covered so much ground today, from the dark matter of the universe to the personal tragedy of Bong-Han Kim, the three-lane superhighway of stem cells and light, and the subway tunnels of cancer.
It's a massive, massive topic.
As we wrap up, I want to leave our listeners, especially the students and the practitioners out there, with a final thought. Because I know that sometimes studying this medicine, practicing this medicine, it can feel like you're defending a ghost story.
You're constantly on the back foot being told, show me the evidence. It's just a metaphor.
And my message to you, after all this, is this. The ancient map isn't a metaphor. It is anatomy we just haven't finished naming yet.
We have found the wire for the check engine light.
We have, and I just want to bring it back to that word, that beautiful, tragic word, one last time. So now,
The live eggs.
those seeds of life.
Bonghan found them, he named them, and then he and his discovery were erased from history. But the seeds survived. The truth survived. They are real. They are flowing through your patients right now as you listen to this. They are the physical manifestation of the potential for life, for healing, for regeneration.
So what's the call to action? What should the students listening right now do with this information?
Be the generation that finishes the job. The door has been cracked open by the physicists in Korea and the biologists at Auburn. Now it's your turn to walk through it. Read the research, demand better imaging technology, understand the science so deeply that you can explain it to anyone. Don't just settle for it works. Find out how it works.
Because the check engine light finally makes sense. We found the wiring. Now it's time to become master electricians.
Exactly.
Thank you for taking us on this journey today. It's been mind-blowing.
My pleasure. Keep asking questions.
And keep looking for the wire. We'll see you on the next one.